So on the back of the packet we did in for the 9.1 stuff, you'll find this sheet, and this just quickly summarizes what we call the law of sines. And so when we want to use the law of sines, we have to have two different scenarios. So if you guys think back to geometry when we did all of the side, angle, side, and angle, side, or angle, side, angle proofs, these were getting us ready to be able to label the triangles in a way that would be helpful for us to recognize a law of sines problem. So we are able to use the law of sines when you are given two angles and a side of a triangle. So this is going to look where you're going to know angle maybe A, and you'll know angle B, and then you just have to know any side. So it doesn't have to be set up necessarily this way, but the important thing to realize when it's a two angles problem is if I told you that this was a 50-degree angle and I told you that this was a 100-degree angle, then we're actually able to find the third angle. So given two angles, you're always able to figure out what the third angle has to be. All right. So the other scenario where we're going to be able to use law of sines is when you know two sides and the non-included angle. So when I say two sides and the non-included angle, if I knew what these two sides were here, the non-included angle would have to either be this angle here, that would be a non-included angle, or this angle here. All right. This is what's considered the included angle between those two sides. So as soon as we get through with that, the sine rule says that sine of an angle A over the side length of A equals sine of an angle B over the side length B, which is also going to be the same as the ratio of sine of the angle C over the side length C. And just reviewing what we had talked about in 9.1, this is if you have your angle A opposite side A, angle B opposite side B, and angle C opposite side C. So let's look at an example of this. Two angles and a side. So triangle ABC, side A is 45. All right, so let's just go ahead and label our triangle ABC. All right, side A is 45, angle A is 97, and angle B is 24. So when it says solve the triangle, that actually means you have to find everything that is missing. So right here, when I see that I have the side and the angle that's opposite it, that's what I want to start with, because now I can have sine of 97 over 45 equals, and if I wanted to find side B first, then I could say sine of 24 over side B. So once I know that, this is just a proportion, so I get to cross multiply here. So I would say B times whatever that value of sine 97 is, equals 45 times sine of 24. So if we plug that into our calculator, and again, make sure you're in degree mode for these. All right, so I'm going to check my mode, and I'm in radian mode, so we're going to go over to degree. And I'm going to type in 45 times sine of 24 equals 18.3, and then I have to divide that by a sine of 97. So I know that side B has to be an 18.4. All right, now if I wanted to find angle C, we remember that the triangles, in a triangle you have 180 degrees, so a 97 plus 24, subtract that from 180, and I know I'm going to get a negative, but I just ignore the negative, so we know that angle C is 59. And now I can set up to find my other side also. So to find C, I'm going to just use the 97 again. I would say sine 97 over 45 equals sine of 59 over c, and we're going to cross multiply again. All right, so if you need to write out the steps, go ahead and write out the steps. But we're going to end up with a 45 times sine 59, and that number divided by our sine 97. And so we get that side C would be a 38.9. Now, one thing I like to bring up, because we want to make sure our answers make sense, in geometry you guys also would have learned the smaller the angle, the smaller the side opposite it. So we just figured out that B was an 18.4, and we figured out that C was a 38.9. So make sure your answers make sense. 24 is the smallest angle, and B ends up being the shortest side. 97 was the largest angle, and so 45 is the longest side. All right, so it's just a nice little check to see if it all makes sense. So if we go ahead and look at another example, all right, two angles and a side. So same triangle here, ABC. I never attempt to draw the triangles to scale. I just label them ABC and fill the stuff in. So side B is 11. That has to be opposite angle B. Angle A is 72 and angle B is 29. So again, what you want to focus in here is the reason law of sines works in this problem is because you can see you have an angle in the opposite side. So you get this nice setup, sine of 29 over 11. And I'm going to go ahead and find side A first, because I would say sine of 72 over A. All right. So I would like you guys to go ahead and pause the video and just solve this one on your own, and then hit play when you're finished with it, because I want to go through the examples at the bottom of the page also. All right, so I went ahead and wrote in the answers there. If you just take a quick second to look at it, angle C was going to be is the largest angle, which is 79. And if you look, I got the side measurement there to be a 22.3. The angle A was 72, and I got the side length there to be a 21.6. So again, it follows the rule. The biggest angle is opposite the biggest side. So 29, angle 29 was only 11, and that makes sense because it is the smallest angle. All right, so let's go ahead and do our last scenario of law of sines today, and then there's going to be a second video that goes through one of the special cases in law of sines. But if we go ahead and we look here, this is an example where we have two sides and a non-included angle. So when I go ahead and I draw this triangle out, all right, I have an A, B, C, and again, how you label them actually doesn't matter at all. And then if I go ahead and I label angle B 115, so you can see already I did not draw this to scale, and B is 3. So this is our nice setup here, and this is how I know it can be a law of sines problem, because I have two things that match up. And then I know side C is a 1.2. So obviously I'm going to have to find angle C first. So I'm going to go ahead and write this out as a sine C over 1.2 equals sine of 115 over 3. So when I cross multiply here, I'm going to get a 3 times sine C equals a 1.2 times sine of 115. So if I go ahead and grab my calculator, we would say a 1.2 times sine of 115 divided by 3, and I get that sine C would be a 0.36. That might have rounded up, I'm not sure. Okay, 2. Let's say 0.363. So we have to remember, and this is what we were practicing in the first part of this unit, to move the sign over to the other side, there's no such thing as dividing here. This is an operation. So to get rid of an operation, you use its inverse. So I'm going to rewrite that as inverse sine of a 0.363. So if we go ahead and put that in our calculator, then I'm going to use second sine, which gets me to inverse sine. And then I'm just going to bring that down because that eliminates rounding errors. And so I get that my angle C is a 21.3. All right. Now, once I know that, we can go and find angle A, right? Because if I know that this is a 21.3, then it's easy to find angle A because I just have to say 21.3 plus 115. And we'll do 180 minus that. And we've got what our third angle is, which is a 43.7. And last but not least, we could take sine of 43.7 over A and set that equal to our sine of 115 over 3. So you guys can go ahead and finish that up and find A. Now, the only thing I think is important here is since these are just ratios, remember there's lots of ways you can set up ratios. So when I wrote the law of sines out up here, I put sine A over side length A. So if we needed to, and if you want to, one thing you can realize, there is nothing wrong with saying side length A over sine A, and a B over sine B, and a C over sine C. So flipping each fraction doesn't change it, and it would actually work this way too. All right, so this one is just another example of what we looked at over here. I'm going to draw the triangle out, and I'm going to let you guys try this one on your own, just like we did with the top two examples. But this is a pretty good introduction to our law of sines. All right, which is helpful because notice these are all non-right triangles, which is why we want to use law of sines as compared to our SOHCAHTOA. So sine of 72 over a 6, and then you know the side length B is 4, so I could say sine 72 over 6 equals a sine of B over 4. And then just go ahead and cross multiply, and don't forget to use this inverse sine button that we were using before. And so pause it again, try them out, and then just check your answers when you're all done. All right, so you can see I went ahead and did the calculation. So we should have gotten a 39.3 for angle B, a 68.7 for angle C, and that would make the side opposite the C 5.9.